Okay, student, this video will explain that how you can write the answer to this question where you are planning an investigation to measure the rate of reaction for the chemical reaction between calcium carbonate and hydrochloric acid. And the instructions in the question are that your answer should include the name and use of apparatus, the procedure, the formula, that how can you measure the rate of reaction. You should also draw a graph, and then you can support your answer with the help of a diagram that includes 1 mark. So there are two methods by which you can calculate the rate of reaction or measure the rate of reaction for this reaction. In this the first method is the volume of gas produced, which is CO2 in this case, and the second method is where mass of the reaction mixture decreases with the passage of time. We will discuss both the methods one by one. First, I will explain the diagram which you can draw to support your answer. So here you see a conical flask which is tightly closed and a delivery tube is passed through its mouth, and on the other end a gas syringe is connected which is supported with the help of clamp and stand. There is a stopwatch we have taken to measure the time. So as soon as we will pull the thread of test tube which is containing HCl, then HCl pour into the conical flask and both the reagent will start reacting and a gas will produce, which is carbon dioxide in this case. As carbon dioxide gas pass through this delivery tube, it will push the piston of the gas tube, gas syringe backward. So instantly we will turn on the stopwatch, and as soon as the piston of the gas syringe stops moving backward, we will turn off the stopwatch, and that is going to measure the time in which the reaction has taken place. Now, what formula you think you should use? We should use a formula, the volume of the gas produced divided by the time in which it has produced. So that is giving us the rate of the reaction. How you can write it? It should be in these points you can use to write your answer. In the answer, some students are writing the name of the apparatus separately, but in the marking scheme, it is suggested that while you are writing the procedure, you can use the apparatus name and how they can be used to help you in plan your investigation. So that is enough to score the marks, where they have asked us to write down the name and the use of apparatus. So in the procedure, if you are writing the name and the use of apparatus, you will definitely score marks. So what the procedure should be? Procedure is how you are going to perform the experiment. First, what you will do, you will take a conical flask, put some calcium carbonate into it. Weight amount of calcium carbonate is suggested to be used. So because you don't want to make one reactant a limiting reactant, so weight amount of calcium carbonate is used, and a fixed volume of HCl is suggested to be used. Once you mix them, you see that in the conical flask, which is tightly closed, closed at the top with the help of a cork, it will not allow the gas which is being produced to release from any other opening. So what is happening when both the reactants are reacting, gas is produced which will push the piston backward. And so this is all the procedure which you perform to do this experiment. So the way you explain your apparatus, the same is the way you are writing your procedure. So this is how you score marks. So as you see, the name and use of apparatus in the procedure you have written. So 3 + 1, 4 marks you have scored. How you are measuring the rate of reaction, that is actually the formula. The rate of reaction is equal to the increase in the volume of gas produced divided by the time in which it has produced. So that you are scoring 1 mark. And a graph is drawn as you see on the screen. The volume of the gas produced is increasing rapidly in the beginning, then gradually slows down and finally stops. When it stops, that means your reaction has stopped. Why your reaction has stopped? Because all the reactant has been consumed. So this is how the graph is drawn, and you score marks for this. And of course, you have already drawn the diagram to support your answer. So you have technically scored full marks in this part. So as there are two methods to calculate or to measure the rate of reaction for this chemical reaction, let's look at the second method. The second method is how you can use the decrease in the mass of the reactant to measure the rate of reaction. For this purpose, we don't need a gas syringe, but we need a reaction vessel, which is in which the reagents has been added, and it is being sealed at the top with the help of a cotton wool. So no splashing or no fumes of acid or no wastage of the acid happens, but the gas can release as soon as it forms. When the gas will release, it will decrease the mass of the reactants, because in the product carbon dioxide which is produced cannot be contained in the conical flask, as the conical flask is not tightly closed at the top. Its opening is loosely covered with the cotton wool, so the gas produced will release and decrease the product's mass. So as soon as the digital balance will show a change in the mass, which will be decrease in the mass, you will start the stopwatch, and when it stops showing the decrease in the mass, the digital balance, then you will turn off the digital stopwatch and measure the time. So this is how you write the procedure. That in the procedure you will take a measured mass of calcium carbonate on the weigh machine, and then take a measured volume of dilute hydrochloric acid. You can write 50 centimeter cube, or you can write measured volume. The both are correct terms in the conical flask. So as soon as the digital balance start showing the change in the mass, you will turn on the stopwatch, and you will turn it off as the weigh machine stop showing the change in the mass. So the formula you will be using, again, the decrease in the mass of the reactant divided by the time in which it has decreased. So that's how you measure the rate of the reaction. So whatever the question is, sometimes they mention you that you use this procedure and sometimes they don't. Then you make a choice that which one you know better to explain, and the name of the apparatus, or which is easier for you to draw. So you choose yourself. And the last part of this question is how can you show the graph where the mass of the reactant is decreasing? As you see on the screen, the graph the gradient of the graph is coming down. So starting in the beginning, the mass of the reactant is more, and it gradually decreasing, and then it finally stop decreasing. This is how you show the graph for the measure of the rate of reaction, when you have chosen to write that the decrease in the mass of the reaction per unit time is giving you the rate of reaction. So that's all for today. This is how you can score full marks by following the rubrics and the marking scheme. And yeah, that's all for today. I'll catch you in the next video. Thank you. God bless. Allah Hafiz.